If you have a 15N120 IGBT and want to check whether it is good or faulty, you can do a quick test using a digital multimeter in diode mode. First, identify the pins when looking at the front of the IGBT with the marking facing you and the 3 pins pointing downward. The pins usually the gate, second one is the collector, third one is the emitter. Then start by checking the short circuit. First one is gate, the second one is collector, and the third one is emitter. First, start by checking the short circuit. Set by the multimeter in continuity or resistance mode and measure between the collector and the emitter. Placed on the continuity meter, then you need to check the continuity is present or not. Now this is open loop. Open loop. A healthy IGBT should not show short circuit. If it does, the device is likely damaged. The next is internal diode. You can see this internal diode. You see this internal diode. Then switch the meter to diode mode. Diode mode, you can see that diode mode. Red probe to the emitter and black probe to the collector. See the red probe to the emitter side. This will be the emitter, and black probe to the collector. Okay. This is the red probe. Red probe to the emitter. And black probe to the collector. You can see the reading. .502. You should typically see a voltage drop around 0.3 volt to 0.8 due to the built-in freewheeling diode. Reversing the probe should show OL or open loop in the conduction. You can see black probe to the emitter and red probe to the collector. This shows open loop. To test the switching action, keep the black probe on the emitter, then black probe on the emitter, then touch the red probe to the gate. This will be the gate. This charges the gate and turns the IGBT on. Now measure between the collector and emitter. The meter should show conduction or lower resistance value. To turn it off, now open loop. To turn it off, short the gate and emitter together for a moment to measure again. The collector and emitter. Turn it off to short the emitter. Collector emitter path should be returned to non-conductive. If the IGBT remains permanently shorted, never turns on or stays even after discharging gate, it is likely faulty and should be replaced. This simple multimeter test can quickly identify most common failure in a 15N120 IGBT.